All right, moving on. So this is the last one, but I want to come back to it because moving on to OO, there's going to be similarities. This is going to look different. Only instead of going underneath continental crust, we've got to deal with another piece of oceanic crust. So what does that look like? That's where we're going. Let's go back to Google Earth. Again, the red line is where there's divergence, mid-ocean ridge system. This plate's going this way and getting subducted underneath South America. Now we're going to look at it the other way. This plate that migrates across the Pacific Ocean over here. Maybe that's not the perfect way to say it, but the plate that bottoms the Pacific Ocean, the ever widening, coming over here and then getting subducted underneath other oceanic crust on this side. So that blue line right there is going to be what we're looking at, and it's similar, right? It's this dark line is going to be a trench, and we're going to have some volcanism behind it on the other side. So let's check it out and draw it. So I'll scroll down a bit. Now I'm going to put the mid-ocean ridge on the other side, just because that's how it's set up in this scenario. If you're keeping your left and your right straight. So again, MORS, mid-ocean ridge system, is somewhere off the page over there. That we should be comfortable with already because we've already done that. And this plate is then moving this way. And it's going to come up to another thin, more dense oceanic plate. Right? On top, let's make the ocean blue this time. We've still got an ocean. But what's going on when they meet? Well, if they're both dense and they're both thin, what happens? As it turns out, the further you are away from that mid-ocean ridge system, I should ask this as a question. If we were in class, I would ask, what would that mean about the age of the plates as you go further and further and further away from the mid-ocean ridge system? Like over here, if we go back to what we did with divergent boundaries, over here, we would find the youngest crust along that mid-ocean ridge system. Some's probably forming there as we speak. And then as it spreads out, we would then find the oldest crust furthest away, out here near the continental boundaries, the passive continental margins over here. So come over here. Look how far this is to get over to this trench, the Tonga Trench. It's a long trip. This crust has been around for a little while. So what happens is that as it gets older, it gets cooler and wetter, and that's going to make it more dense. The older crust tends to be more dense. It's been around for longer. It's cooled off more. It's compressed more. So what happens when they hit each other is that the older of the two tends to be the one that will subduct. So just like the last one, again, this should look familiar. Subduction is going to be the word. You can spell it right. For where this gets sucked down underneath other oceanic crusts. As it happens, it yanks down and it gives us a trench. The deepest trenches on the planet are a result of these oceanic to oceanic convergence, pulling down. Mariana's Trench, Challenger Deep is that kind of scenario. Get to that same depth over here, and we start getting the melting and those plumes of magma that are going to rise up, and they're going to come up and hit that thin ocean crust and melt their way right through it. In which case we'd have a volcano again, only it's a volcano that's underwater. So it would build and go off and go off and go off. I mean, picture this like a conveyor belt to the grocery store. It's just going and going and going, coming down, coming down, coming down, melting, melting, melting. It's like a consistent source of magma. So your volcano through the years can get bigger and bigger and bigger until eventually it pokes right out the surface of the ocean. So these are huge. Well, let's draw one more with that. Because if you consider that that volcano comes from the floor of the ocean, they're huge. So what we got here would be an volcanic island arc. Mentioned volcanic island arc is your typical landscape that you would see from an ocean to ocean convergent boundary. And again, the mechanisms being very similar to what we saw over here. This going underneath South America, melting through continental crust. This going underneath that plate, melting and creating a volcanic island arc. So I don't think there's anything really I missed on that. So let's see where on Earth we are. The reason I picked this one, let's do the easy one first. The Aleutian Islands is the easy example of this. So where you put, where's the typical one? The Aleutian Islands off of Alaska is very typical. Let's hit that volcano layer, and all those little triangles popped up. I realized I said rectangles in the last video. Sorry about that. All those little triangles pop up, giving us where these volcanoes are. So lots of them, right? Really, if you've ever heard this term, the Ring of Fire, there's a lot of this going around the outside of the Pacific Ocean. Up here in North America, we've got a little bit of ocean to continental, but there's some volcanism with that. Once you get up here, lots of volcanism down through this part of Russia, over through Japan, Marianas, all of that. It's really all over. But if you want to just stick to one, the Aleutians is the easy one, the Aleutian Islands right there. The reason I wanted to do the Tonga one, I guess, is twofold. One, you can see this all is one system now. We could do one cross-section from subduction underneath the continents in South America up to the mid-ocean ridge and over to subduction underneath an oceanic plates over here at the Tonga Trench. We can zoom in on these islands. The reason I picked this one specifically, last year there was a eruption here. Now, if you turn, and it was enormous, and I think we'll look at it more specifically when we go to volcanoes specifically. But what the heck, for now, Google Earth has this handy go back in time feature. So there it is now, that little bit. I'll stay at the same zoom level, and I'll just go back a couple of readings. And they did one while it went off. So there it is with the plume coming out. It was an enormous event. And there it is before. All right, uninhabited, fortunately, I believe. And there, I went and messed with the zoom, right? But if I just turn that off, watch what happens to the size of the island. Oop. All right. Go back one more time since I kind of messed it up. From that to that, it was a huge event. Shockwaves that went around the world multiple times. Tsunami, big, blasted an unprecedented amount of water high up in the atmosphere. A really huge event. And indicative of what we should see here. It's not a surprise. This just was a big one. This plate subducts underneath. That magma melts once it gets deeper in the earth. And that island arc that forms is a result of that melting. What do you think? Getting there. Down to a couple to go. But yeah, I think that should do it. All right, everybody. We'll see you on the next one.